Utilizing these five main components can help us to graph rational functions. So the first component we're going to want to take a look at is the domain of the function. And our domain will be all x values for which f of x does not equal 0. So what we're going to do is set our denominator equal to 0. So x squared plus 3x plus 2 is equal to 0. And then set that into two binomials. So we'll have x plus 2 and x plus 1 equals 0. And then solve for x, and we'll have x equals negative 2 and negative 1. So we know our domain for this function will be all real numbers except for when x equals negative 2 and negative 1. And now going off of that, we're going to want to jump into our second component, which is solving for any excluded values or discontinuities. And we can either have vertical asymptotes or holes. But first we're going to want to solve for any holes, since holes are removable. So to find any holes, we're going to want to factor the numerator and the denominator. And if there is the same factor in both the numerator and the denominator, that's going to be our hole. So we'll factor out both the numerator and the denominator, and we'll get 2x plus 3 in parentheses, x plus 2, and in the denominator, x plus 1, and x plus 2 that we solved for when looking for our domain. So from looking at this, we can see we will have the same factor in the numerator and the denominator, so that's going to be our hole. And solving for our hole, we're going to set that factor equal to 0, and then solve for x, and we get x is equal to negative 2. So now we have the x value for our hole. And to get the y value, we're going to plug that x value into the remaining equation. So we'll have 2, negative 2 plus 3 in parentheses over negative 2 plus 1. And when we solve, we'll get negative 2. So we know that our hole is going to be at the coordinates negative 2, negative 2. And since that was our only hole, that leaves us with x equaling negative 1 to be our vertical asymptote. So our vertical asymptote is going to be at x equals negative 1. So our third component is going to be solving for n behavior. Now when we solve for n behavior, we first look at our horizontal asymptotes. Now to solve for these, we're going to compare the degrees of the numerator and the denominator. And when doing so, we can see that in our equation, our highest degree is a 2 in the numerator, and our highest degree is a 2 in the denominator. So that means that our horizontal asymptote will be our leading coefficients of the numerator and the denominator divided by each other. So our leading coefficient of the numerator is 2, and even though there isn't any integer here, that's going to be a 1. So we know we are going to have a horizontal asymptote at y equals 2. And I'll just put a square over that just so I know to remember that and keep that in mind. Now our fourth component is going to be looking for any intercepts. Now to find our x-intercept, we're going to set the numerator equal to 0. So we'll have 2x squared plus 10x plus 12 and set that equal to 0. And then factor that out like we did when solving for our excluded values. So that'll just leave us with 2 in parentheses x plus 3 and x plus 2. Now when looking at this, we could plug in both our negative 3 and negative 2, but since we know we have a hole at x equals negative 2, that means we're going to have our x-intercept be at x equals negative 3. So we'll just keep that off to the side. And to solve for our y-intercept, we're going to set all the x values in our equation equal to 0. So doing so, plus 10, 0 plus 12, all over 0 to the second power, plus 3 multiplied by 0, plus 2, and that leaves us with just a 12 over 2, which equals to 6. So we know that our y-intercept is going to be at y equals 6. And again, we'll just keep that in mind. Now our fifth component is just going to be testing the intervals. But before we do that, we're just going to want to take a look at all our information we have set in front of us. So now we know that our domain will be all real numbers except for x equals -2 and -1. We're going to have a hole at -2, -2, a vertical asymptote at x equals -1, and our x-intercept will be at -3, and our y-intercept will be at y equals 6. So at this point is when I'll just show you the graph I previously did. Now here we can see our domain, our hole at -2, -2, our vertical asymptote at x equals -1, our horizontal asymptote at y equals 2. So after graphing that, I'll go in and graph our x and y intercept, which is at -3, 0, which is right here, our y-intercept, which is at 0, 6, which is here. And then after that, I just picked a point that lays on this side of the vertical asymptote. So I picked this point of -5, 1, and that helped me find out the overall layout of how the graph would look on this side of the vertical asymptote. And then on this side, I picked 2 points at 1, 4, and 7, and 2.5, and I just plugged them into the equation just to figure out the layout of this graph, and this is what I ultimately ended up with.